Energy 1 changes in BREEAM New Construction 2011. This short presentation is split into 3 parts. Part 1 will briefly outline the Energy 1 methodology and what has changed. Part 2 will explain to assessors and clients exactly how anyone can calculate Energy 1 credits. And Part 3 will provide further details on the analysis and reasoning for the changes. Part 1. Energy 1 methodology and what has changed. A new Energy 1 calculation methodology was introduced within BREEAM New Construction 2011. Since its release, BRE Global have received feedback querying some of the results generated using the new calculation methodology. BRE Global therefore have gathered and analysed energy performance data for a large number of existing buildings to investigate the issues which have been raised and carry out a general review of the calculation procedure. As a result of this review, there will be some changes made to the existing calculation methodology. Before explaining the changes, it might be helpful to briefly review the current methodology. The number of BREEAM Energy 1 credits that a building will attain will be based on the Energy Performance Ratio, EPR, for new construction. This ratio is expressed as a number between 0 and 1. The overall EPR is made up of 3 parts: demand, consumption, and CO2 emissions. Individual EPR values for demand, consumption, and CO2 are added together and weighted to get the final EPR. The EPR has been created to recognise and reward what is most important in designing excellent energy performance in buildings. Rather than simply encouraging bolt-on solutions to reach zero carbon emissions, it rewards a considered approach across the 3 parameters of demand, consumption, and finally CO2 emissions. The demand is firstly minimised through optimal building design, fabric, and air permeability. Once demand is minimised, we look to meet that demand in the most effective way through the specification of the most suitable and efficient systems with good distribution and controls. Both of these first 2 parameters will influence the third, which is CO2 emissions. The fuel type also has a bearing on this part. Raw building data is converted into the final ratio via translators in the BREEAM methodology. It is these translators that have been recently reviewed through extensive modelling of existing stock. The feedback received and the analysis carried out can be grouped into 4 main areas. Number 1, the accuracy of the existing demand, consumption, and CO2 emissions translators. Number 2, the relative performance of naturally ventilated, mixed mode and air-conditioned buildings. Number 3, the performance of buildings incorporating combined heat and power systems. And finally, number 4, the performance of the Energy Performance Ratio credit benchmark scale. Summary of investigation findings. The original translators were based on an original set of modelled buildings. In carrying out subsequent investigations, a larger set of buildings were modelled to further test the accuracy of these translators. In terms of the first 2 areas of investigation, the accuracy of the translators and the relative performance of buildings within different servicing strategies within those translators, it was found that no change was needed. The new methodology is working as intended, so the translators of performance will continue to be based on the performance modelling of the original stock of buildings for the 2011 version of BREEAM New Construction. The new building data will continue to be modelled to increase the accuracy of the translators. These results will determine translators in future updates to BREEAM New Construction. The third area where the performance of buildings incorporating combined heat and power systems was investigated did find that a change to the methodology was needed. As a result, the energy consumption translator has been updated to consider primary energy rather than delivered energy to ensure that CHP systems are not penalised in BREEAM 2011 New Construction. Finally, Area 4. This also found that a change in methodology was needed. The original credit scale was found to be too harsh, and as a result, the BREEAM credit scale has been replaced with a new scale for use with the 2011 version of BREEAM New Construction. Further details of the analysis and reasons for the changes are available in Part 3 of this presentation and in the published Methodology Review technical paper. Part 2. How anyone can calculate Energy 1 credits. This part will explain what simple steps should be taken to determine Energy 1 credits in BREEAM New Construction 2011. The Energy 1 credit calculation is based on outputs provided by the National Calculation Methodology used to demonstrate compliance with Part L of the Building Regulations, Conservation of Fuel and Power. The engine for this calculation is the ISBEM software, which drives the outputs provided by all accredited energy assessors. Ultimately, these outputs are in the form of the Bruckle document and the Energy Performance Certificate. It is the Bruckle document that is needed to determine the BREEAM Energy 1 credits. Because of the change in methodology, some of the information now needed for the Energy 1 calculation is not available. The original approach was to extract key data from the Bruckle output document, an example is shown in the table, and enter this into an Energy 1 calculator tool, and this would determine the credits awarded. This approach is no longer valid, as we now need primary building energy and not demand, and primary energy is not provided in the current Bruckle output document. Eventually, the output from ISBEM will be adjusted to make the primary building energy available in the National Calculation Method outputs. However, until that happens, the simple solution is to use the BREEAM Compliance Checker website. The BREEAM Compliance Checker website is available at www.epbhub.net/BREEAM in capital letters. It is a publicly available service free of charge. After a simple registration process, you simply upload the Bruckle document. This must be the file with the INP suffix. Upon the press of a button, the results similar to the ones shown on this page will be displayed. These include the EPR and the corresponding number of Energy 1 credits earned. Assessors carrying out an assessment then simply transfer those results to the scoring and reporting tool. This must be version 2.8 or above. Similarly, they could be transferred to the pre-assessment estimator, version 2.5 or above. The Compliance Checker website does provide the exact number of credits earned for the EPR, so there is no need to look up in the table shown here the number of credits awarded. However, the new scale is shown here to indicate the changes and is available in the Methodology Review technical paper and will obviously appear in the updated BREEAM 2011 manual. It is worth noting that while the Compliance Checker website does show the credits scored, it doesn't say if they've achieved the minimum standards with regards to CO2 emissions. The assessor still needs to use the pre-assessment estimator or scoring tool to check this. The full technical paper of the Methodology Review is available in the Resources section of the BREEAM.org website. A summary of the review will be covered in Part 3 next. Part 3. Further details on the analysis and reasoning for the changes. This part of the presentation will cover how the translators work within the methodology, the findings of the investigation into the accuracy of existing translators, with particular regard to the three parameters of demand, consumption and emissions, the accuracy of using a combined translator for different servicing strategies. We will then look at the study of delivered and primary energy with regards to combined heat and power and the reason for the change in approach, and finally how the credit translator investigation determined a necessary adjustment. How the translators work within the methodology. The overall EPR is made up of three parts. Individual EPR values for demand, consumption and CO2 emissions are added together to get the final EPR. In terms of calculating the final score, the support tools will do all the working out for the assessor, but it helps to understand how this calculation is working. There are 3 steps to determine the EPR, and it is in step 2 where the translators apply. Step 1 is to compare the actual performance of the building you're assessing with the notional building or target emission rate in the case of CO2. This ensures a fair evaluation for all buildings. The notional building is actually set up to be a building of the same size and shape as the assessed building, but with predefined performance parameters such as U values and system efficiencies and so on. Step 2 is to translate this into an EPR. This is done by comparing the assessed building with a sample of modelled building stock to see how it rates relative to them. The better it rates compared to the others, the higher the ratio will be. 3 individual ratios, one each for demand, consumption and CO2 emissions, will be determined. Step 3 applies a weighting to each of the 3 individual parameters, and the overall ratio is obtained by adding these together. In a nutshell, Step 2 will measure how your building compares with others, and give it a score accordingly. The better it compares, the higher the score, simple as that. You can see on this chart the bell curve or normal distribution. This curve represents the range of scores a range of different buildings typically achieve. This range of results is based on a modelled set of buildings. The best performing building in the range, the average and the worst performer can be seen on the chart. The nearer to best the assessed building is, the higher the score. The EPR translator curve in blue indicates the allotted EPR value given to an individual score. If the assessed building's individual score was positioned as indicated by the light green arrow on the x-axis, then the resultant EPR can be read off the y-axis, in this case a score of 0.8 on the vertical scale. This graphic is just to show the theory behind the calculation, and the supporting tools will do all the calculating for you. The accuracy of existing translators investigated. In investigating the accuracy of the existing translators, a large set of available energy performance data from actual buildings was analysed. The bold lines on the chart represented the results of the new analysis and effect on the translator if based on this extended sample. In this chart of the demand, you can see the grey bold bell curve is lower and flatter, indicating a much broader range of performance. The resultant bold red translator curve lies inside the existing translator. This tighter curve indicates that buildings currently score slightly higher than they would do if the translator was based on the expanded set of building performance data. In a similar way to the demand parameter, the consumption parameter would also become slightly more stringent if based on the expanded set of building data. In CO2 emissions, the existing and updated translator curves are almost indistinguishable. In summary, the curves for the updated translators are very close to those of the existing translators, which suggests that the original stock of buildings used to inform the translators is representative of the actual building stock, and the translators are working as intended. The relative performance of buildings with different servicing strategies. The next part of the analysis looked at to what extent having a combined translator was justified for different servicing strategies. This analysis was based on the extended model data. The graph shows that the demand translators for naturally ventilated, air-conditioned and mixed-mode buildings are all within a reasonable tolerance of the combined translator, with the naturally ventilated curve being the closest match. Based on this dataset, it can be seen that the effect of using the combined translator is to slightly penalise air conditioning and mixed-mode buildings, whilst naturally ventilated buildings achieve a slightly higher energy performance ratio than they would if individual translators were being used. However, it should be noted that the sample of mixed-mode buildings was too small to make this curve statistically valid. This graph shows that the consumption translators for both naturally ventilated and air-conditioned buildings are very close to the combined translator. There is, however, a marked difference between the combined and mixed mode translators, which suggests mixed mode buildings find it more difficult to score well in the consumption parameter and are therefore being penalised by using a combined translator approach. The CO2 translators shown on this graph mirror the results for the consumption parameter, with the combined translator proving to be a very close approximation of the naturally ventilated and air-conditioned buildings, whilst there is a marked difference with the translator for mixed mode buildings. On the whole, the results are very positive in that they suggest both naturally ventilated and air-conditioned buildings are treated fairly by a combined translator approach. The consumption and CO2 emissions translators for mixed mode buildings suggest that it may currently be more difficult for mixed mode buildings to score well in the consumption and subsequently CO2 emission parameters. However, BRE Global have only received limited data on mixed mode buildings, and as such it has not yet been possible to establish the accuracy of the updated mixed mode translator curve or the reason for this discrepancy, and therefore no firm conclusions can be reached in this respect. BRE Global will continue to review the energy performance data received for mixed mode buildings and will carry out further analysis to establish the validity and reason for the current discrepancy. The performance of buildings with combined heat and power systems. The next thing to be considered was the performance of buildings with CHP systems. The main qualities illustrated on this diagram that illustrate the potential penalty in the appraisal of CHP systems via the National Calculation Methodology is that the National Calculation Methodology is based on delivered energy in the middle of this diagram and not primary energy to the left. In generating electricity for the national grid, the power station efficiency, more specifically the losses, lie outside the model, i.e. are incurred prior to the delivered energy being measured. For combined heat and power, however, the losses associated with electricity generation lie inside the model, i.e. after the delivered energy is measured. In looking at some typical summary data for conventional heating, ventilation, air conditioning versus CHP installations, you can see that for the same energy demand in the final column of 10,000 kilowatt hours, CHP has a greater delivered energy but lower primary energy total compared to a conventional HVAC system. From this simple analysis, it is clear to see that CHP is unfairly penalised in this instance, and a much better reflection of overall system efficiencies would be obtained with the use of primary energy as the starting benchmark. The Energy 1 BREEAM 2001 new construction methodology has been adjusted accordingly. The performance of the EPR credit benchmark scale. The existing indicator in blue was originally adopted on the basis that it should be easier to make initial gains in building performance, while it becomes harder to make further gains as the overall performance of the building improves. However, this has already been accounted for to some degree by the individual translators of performance, which means applying a further correction through the EPR credit scale is unnecessarily demanding. The energy performance data received also has shown that a significant number of buildings struggle to reach 6 credits, i.e. the point where subsequent credits become relatively easier to achieve, which suggests that the initial EPR credit ratio is too harsh and the scale is not working as intended. The scale has therefore been adjusted to that illustrated by the red line in this graph. The corresponding credit table again is as follows. This new scale is now incorporated into the current version of BREEAM 2011 for new construction. So in summary, the translators of performance will remain for BREEAM New Construction 2011 current version, and will be updated as necessary to reflect the latest real building energy performance data available at the time of subsequent reissues of the scheme document. The use of the combined translators to represent buildings with all servicing strategies will remain for current and future versions of BREEAM new construction. The energy consumption metric will be revised for the current version of BREEAM new construction to consider primary energy rather than delivered energy in order to address a flaw which currently penalises CHP systems. And finally, the existing EPR credit translator will be replaced with a linear translator for use with the current version of BREEAM new construction. Thank you for listening to this presentation.